What's up guys, Fantasia here with another tutorial in Allegro Game Programming. In this video we're going to be programming our first Allegro game project, and it's going to be Pong. Let me talk a little bit about the design of Pong. Well, first off, Pong was built in the 1970s by an electrical engineer for Atari. His name was Alan Alcorn. And the reason I use the term built is because in that time video games were not written in computer software like we're doing today, or like modern times. They were actually built using electric circuits, and there were no microprocessors, so they had to be built using discrete parts. So that being said, just a little bit of history of Pong. Let's go into the game design of what Pong is and how it plays. Okay, guys. So in Pong, there is very little amount of objects in the actual game. So what you have is you have paddles and a ball. Okay, and essentially the game is plays like table tennis. Okay, so you have two is a two-player game. You have two paddles, and they both move in the vertical direction. Okay, here as indicated by these blue arrows. Then you have a ball. Okay, you have a single ball, and it moves around the screen with some velocity. And the goal of the game is for each player to score as many points. And typically a score there's a score counter, but in any case, the ball glides across the screen and it's going to hit the paddles, and then it's going to bounce off, as seen in this diagram here. So it's going to come and bounce off the paddle, and if the ball reaches the edge of the screen, or it reaches out of the field, then that's going to count as a score, a point for the person that made that serve or that hit. Um, and then the ball is reserved, and then the game just goes on like that. So it's a very simple game. It's pretty much the hello world of game programming. I don't think there's another game that's simpler than Pong, but that's essentially the game in a nutshell. So this is what we're going to be writing in Allegro, and let's get to it. Okay, guys. So um, let's get started with writing Pong. The game itself is going to be using every single aspect of Allegro that I've gone over thus far, including collision detection between the paddles and the ball. So let's go ahead and get started from the beginning um, with pretty much a blank empty project. If you don't know how to start Allegro projects in CodeBlocks, you should go and watch my video on how to do that. Um, I'll put a link of that video in the description. Um, and Other than that, let's go. So we need to start with a main, of course, because every program starts with that. And then, of course, we have to initialize Allegro. Okay, so we do Allegro init. Okay, and then we want to install the keyboard. Okay, next we're going to set the screen. We're going to set the color depth. Okay, so we need to call set color depth, and we're just going to set the depth to whatever our current desktop color depth is. So we'll just do desktop color depth, and this function set desktop color depth just returns whatever your color depth is for your system. And then next we're going to set our graphics mode. We're going to set it to a window, so we're going to do GFX auto detect window, and we're going to set it to a very small resolution, our basic 800 by 600. Yes, I realize, computers today can go well beyond that. We'll just keep it simple for now, just a simple resolution, and then set the virtual screen to 0. Okay, so we need a return 0. Oops. For that, and we also need to do end of main. Okay, so of course we need to include the library, and also note that the library is linked already. You need to link the Allegro library in with your project so that it'll compile properly, and then we will save. um, Next, we're going to start with our bitmap. We need to create a bitmap, so that we'll call it layer, and that equals create bitmap, and that has the same dimensions as our screen, our window. Okay, and we're going to put these numbers in a constant later on, just so that we keep numbers out of hard-coded numbers out of the parameters. And then we're going to clear the screen, clear the color. So screen color equals, let's see, let's make the screen color, let's make it white for now. Okay, see, we're looking good so far. Okay, so next is our game loop, right? So we need the game loop. So while not key escape, then do some things. Okay, so our game is going to go inside this loop here, and then we're going to want to also set up our timers. Remember, the timers ensure that the game runs at the same speed on all computers. So we need to install our timers. So we'll do that before. It doesn't really matter when you install them, just install them at some point. Install timer, and then we're going to want to start a timer after we install them. Oops, not that. We're going to do install int x, and we'll come back to this later. Okay, so far we've got our screen, our timers, our graphics, and the startup. So we're getting there. Now we need to draw or blit the screen, or blit our layer to the screen. So we need to do blit, and if you're a little rusty on blit, I have a video on just that. I believe it's lesson 2 or 3, one of those. And then we're going to blit the layer to the screen, and no clipping, and that's 800 by 600, and it's screen, not scree. Okay, next we're going to clear the color so that we don't leave trails. Clear the color of the screen to or the layer, actually clear that to our screen color, which we've defined up here. Okay, so it's going to clear it to white, because make call 255 255 255 is white. Its RGB value is white. Okay, next, well, actually, I think we actually have enough here that it will run something, but we need to destroy the bitmap. Okay, so let's compile this. Go up here and do compile, build. Oh, and it says I need a, oh, parentheses. Wow, didn't miss that. Install X. Oh, it doesn't like that. Yeah. We'll leave that. We'll come back to this, trust me. There we go. Now let's run it. We should have a white screen, and we do. So this is our window that the game's going to run in. So it's called Pong because that's what I've named the project. But this is essentially what the game's going to run in, this window here. So now we're going to hit escape so that it closes out. Okay, so far so good. Next we need to set up our timers completely. So like I said in my previous video about timing, we need to set up a clock sort of. So we're going to do volatile, and we're just going to call it the core clock, and we're going to initialize that to 0, and it's actually a long hint. Okay, and then we're going to initialize a variable called core clock rate, and this is going to be our frames per second, which is going to be set to 60. Okay, and now we need a function that our timer is going to call every time that there's a tick. So it's going to be increment core clock, because that's what it's going to be doing. And it's going to simply do core clock plus plus. And then don't forget our end of function. Okay. Now we're going to go back in here into our timer routines, and we're going to lock the variables. Lock variable, and it's the core clock. We're locking that, and we need to lock also the function. So lock function increment core clock. Okay, and so next, now that we've locked it, now we're going to go ahead and install our timers. So we're going to call increment core clock, and then we're going to call it at a frequency of beats per second to timer, and it's going to be the core clock rate, and that's going to be 60. So like in my previous video, this is going to have the program run 60 times. The loop is going to run 60 times a second. Okay, so that looks good. And now we can go ahead and finish off the game loop code with, this is kind of like a hang up scenario. The while core clock is not while it's 0, we're going to rest to give the logic time. To execute, and then while the core clock is 1 or is greater than 0, not necessarily 1, it's going to be doing the logic part, and the logic goes in here. Zoom down here, there we go. So now this is actually where our logic gets executed. So now we're going to do old ticks equals core clock. This is all part of the regulated timer routine. Go back to rewatch the video on game timing to catch up. Core clock minus, and then if all ticks is less than or equal to core clock, then we're going to break this and jump out. the loop, and then we're blitting it and clearing it to color. Okay, so let's save that, build it, and then run it. So far it doesn't look any different because it's not. I mean, it's just doing a bunch of internal different things, like instead before it wasn't regulated, now it's a regulated loop. Okay, so now we can get out of that. Okay, so this code right here that I've written so far is the bare minimum for any Allegro game that you want to write. Okay, so it sets up basically your startup, and we can go ahead and label what it does. So this is your Allegro startup. Okay, it basically takes care of the initial things that the library. So you're starting the library and installing the keyboard, and then your graphics modes, graphics setup. You're setting up your timers here. Oops. Timer setup. And well, yeah. And then this is your game loop. So we'll go ahead and label that just to make the code easier to read. Game loop there. Okay. So now this is, like I said, the bare minimum for what we need for our game. So now what's next? Well, we need paddles, right? So we need to have some way to actually hit the ball with, and we need a ball. So we need paddles and a ball. Well, right now we have our basic game structure here. So I believe this is a good stopping point. Just getting the actual initialization code running. Okay, so in the next video we're going to actually be adding some things in to the game. So catch you guys later.